Hello everyone, welcome to this video on methods to find the local optima of a given function. So we have already seen what is local optima and the things for a function, and now we will discuss about the several methods available for finding the local optima in a given function. The first method available is bracketing method. The second method is region elimination method. Third is about point estimation method, and fourth is about gradient based method. Now we will discuss about the first method, which is bracketing method. Bracketing method is one of the very simplest of all methods, and it is used to find out the optimum. It may be either a maximum or minimum within a given function by breaking the function into equally spaced intervals and substituting the value of x in that particular function, finding out that value. So it consists of two phases. The first phase is to find out the lower bound of lower bound and the upper bound of the function using a crude technique. The crude technique may be like substituting some random values like 1, 10, hundreds, thousands, and so like that, and you can find out within which bounds your value actually changes from maximum to minimum or something like that. So in phase 2, after finding out the upper and lower bound, we are going to use one sophisticated technique to actually locate where actually your solution lies or your optimum value lies. So we will discuss the exhaustive search method used to find out the local optimal point. So we will discuss the steps directly. This step 1, we are going to find out the upper bound and lower bound. This is nothing but the phase 1, and the other thing is to also decide the number of intermediate points we are going to decide between these upper bound and lower bound. Say for example, we consider it from upper bound as minus 10 and lower bound as plus 10, and between these bounds how many intermediate points we are going to check, that is n. Say for example, if we have intermediate points as 20, then our step size is 1. So minus 10 to plus 10, we are having 20 intermediate points. So setting the upper bound as x1 and the delta x, that is the change step size, the number of things is the difference between the upper bound and lower bound divided by the number of steps. So you will get the change in the step size. So x2 is nothing but x1 plus delta x, and x3 is nothing but x2 plus delta x. That means we are taking 3 points starting from the lower bound, that is x1. So after getting this 3 point, we are substituting this 3 point in the function, and we are getting the function values f of x1, f of x2, and f of x3. If f of x1 is greater than f of x2 and f of x3 is less than f of x2, then the solution lies between x1 and x3. That minimum point lies between x1 and x3. I am taking minimum. I am searching for minimum function. So if you get this as a condition, then we can terminate. Else what we do is we shift the x2 to x1, x3 to x2, and we are finding a new value for x3, that is x3 plus delta x. That means we have moved our intermediate point to the next step, and we go to step 3 and check whether x3 is the upper bound. If it is the upper bound, then we are going to step 2 again and finding the condition. If this condition satisfied, we terminate. Or else what we do is we conclude that there exists no minimum between a and b, and we have to find out a new new bounds. So let us see a problem. Let us have a function minimize f of x equal to x square plus 54 by x in the interval 0 to 5. Now for example, we have taken the lower bound as 0 and upper bound as 5, and here we are taking a as 0, p as 5, and n as 10. That means 10 intermediate steps. As there are 10 intermediate steps, we are calculating the incremental step size, that is 0.5, and accordingly we are starting to find out the minimum point. So iteration 1, so we are using step 1. So x1 we are taking as 0, x2 as 0.5 and x3 as 1. We are substituting these values in the function x square plus 54 by x, and we are getting these values as the function values, and we check the condition. So the condition comes like this, which is not satisfied as per step 2. So we go to step 3 and we check whether we have reached the maximum bound. So we have not reached, so we go to step 2 again. So we resubstitute x2 in place of x1, x3 in place of x2, and we increment x3 by delta x, 1 to 1 plus 0.5 as 1.5, and substituting these x values in function values, we get these values, which the condition comes turn around like this. So we continue like that, and finally we can see that the condition gets satisfied, that is f of x2 is less than f of x1 and less than f of x3. So the minimum point lies between x1 and x3, but we cannot say that x2 is not exactly the minimum point. So if we want to say that if we want to increase the accuracy of the solution, then n has to be increased. So if we want to increase the n to 3 decimal points, then you can use this formula, 2 by n into b minus a. If we want to increase the n to 4 decimal points, then you can put instead of 0.001, you can increase one more decimal point here, 0.01, then you will get your solution accuracy in 4 decimal point. Thanks for listening. Let's meet in next video. Thank you.